Thanks for joining our webinar, even though it's a beautiful day outside, and I'm sure we'd all love to be elsewhere very soon. Give folks another, let's see, it looks like it's sort of slowed. So I guess we'll go ahead and get started. Okay, welcome everyone to RIEEE's last webinar of spring 2026. My name is Grace Plummer. I'm Managing Director of RIEEE, and we host these webinar series to highlight existing and emerging research strengths at Appalachian that align with the Institute mission and things that help us build capacity for research and impact across campus. So today's session, we're going to hear from some of our friends in ITS here at App State about a new computing resource that's available to faculty and staff. It's NC Share. And our presenters today are the IT research computing team, so they'll provide an overview of NC Share. It's a statewide cyber infrastructure that leverages the power of high-speed networking, shared computational capacity, and state-of-the-art GPUs to create a path toward innovation in higher education and research. It's supported by a grant from the National Science Foundation Cyber Infrastructure Program. And today's session will describe how the computing and storage resources that NC Share offers could benefit your work, and explain how App State faculty and staff can access the resource. So before we get started, I wanted just to introduce that Lauren Essick, who's a Research Development and Operations Manager here at RIEEE. She does all the back-end work to organize these webinars. Thank you, Lauren, for being here. And without further ado, I'll go ahead and introduce Justin Cervero, who is the Director of IT Systems and Research Computing at App State and ITS. He oversees campus computing systems, including high-performance computing, research support, and Appalachian's participation in NC Share. So Justin, if you would go ahead and introduce your team and kick us off. Thank you so much for being here.
Thanks, Grace. We really appreciate you having us. It's really good timing. We've had some developments in the last few weeks for the NC Share platform. So again, I'm Justin. I'm a director in IT. My team handles kind of back-end systems for the university. In addition to that, we are also charged with research computing resources. We have spent a number of years building out platforms locally for departments who have need for heavy compute. But it's been a challenge, primarily from a fiscal standpoint. High performance computing is really expensive in a number of ways, and it has only grown more so in the last year. I'm sure all of you track developments in the AI space, and from there, it has really made it more of a challenge for institutions our size to bolster our platform simply because they've become prohibitively expensive. Everybody in the AI space is buying up all of the resources that we need to provide the tools to you. NC Share, as Grace mentioned, is a consortium based from an NSF grant that started a few years ago, and boy, did they time it perfectly, because they purchased right before the market sort of skyrocketed. The resources they bring to all public education institutions in the state are significant. They have invested millions into this platform, and they are giving it to all of us for free, which, when some of you may have attended the Recon event back in the fall, and I talked about wanting to use this as a bridge. We built a high-performance computing platform without GPU, and it has served us well. I want to use NC Share to get us to a point where we can build our own smaller scale platform for internal use. And I think my team will get into a couple of use cases where like we still need to do that. But this bridge is going to be a little bit longer than I expected it to be, based on state budget, based on the cost of compute. So I'm really thankful that this opportunity came when it did. We are, I guess, we are a liaison level right? Yeah, we're liaison level participant. So what that means is that my team supports Appalachian's use of this platform, but everything has to flow through us, and we provide frontline support, and we get a little bit lower level access to some of the resources. Some of the primary participants get heavier compute or more compute resources than we do. But honestly, what we get access to is already significantly more than what we're able to provide on campus right now. Um, the interesting part is this is not just about research computing. It's also about classroom activity, right? That as my guys will describe to you, that we've got kind of two parts of the platform. One is for use in the classroom. One is for use in research. And we've been exploring with early adopters on campus what use cases. I see. I'm going to answer that question in just a second, Abba. We're exploring like what are the best resources we can shift off of campus so that we can then appropriately handle the loads that other folks need to stay on campus. Primarily, that's going to be about data security level. I think I don't think we can move up to that. I'll Jeff may be able to speak to that better, but I think primary access is really only for the groups who were sponsored as part of the grant. That's probably NC State, NCA&T, Duke's involved. I think all of our participants. Thank you, Grace. I will keep that in mind. Yeah, we may be able to describe that better down the road. So if Jeff is ready, I will hand it over to him to start talking about the technicals. Jeff Tickle is the manager of both our Linux systems and our research computing team. He and Tobi and Leander have been the leads on this for the last year. They've been doing all the technical work. They're going to guide you through how you actually take advantage of the system, what the system actually is, the technical details of it, and they'll probably be able to better answer questions than I can. So, Jeff, and if Monty requires a little bit of attention, let me know and I'll jump in.
Sounds good. He might end up on camera here. Got my son with me today. Um, anyway, I have Jeff Tickle, manager of Linux and Research Systems, and I've been uh, it came up that someone wanted to buy an HPC about 10 years ago, and they said, "Why don't you do it?" And ever since then, I've been kind of uh, doing some of the legwork here. Now I've got a team, and I want to thank Leander, Hutton, and Tobi Azeez for joining us today. They're going to run through a lot of the technical information on the slides here. But let me pull up the slideshow. And are we seeing this? All right. Wouldn't be a Zoom webinar without asking that question. Um,
And
so
Jeff, while you're getting started, I thought I skipped over something in my intro that we'll hear from the team, and then we're going to have some Q&A at the end and a live demo. We do record these for our YouTube channel, so we'll stop the recording after the presentation bit, and then we can just have conversation in the live demo off camera, of course. So go ahead, Jeff. Sorry for the interruption.
No, thank you for that. That's perfect. Yeah, we had the demo scheduled right in the middle here, and we're going to move that off to the end, so there's no problem. But yeah, let me dive right in here. This was supposed to be in the background while Justin was talking, but here we have NC Share with 21 institutions and no cost to us, 32 NVIDIA H200 GPUs. And we discussed the liaison level stuff. So we'll move it on down. The early adopters bit there is specifically about the GPU access. So that is by request, and we'll discuss how that process works. And let's see, could I get Leander to, or is this
It was me.
it's Tobi, sorry, go ahead.
Very good. Hey everyone. So this is basically a brief overview of the hardware differences between our on-premise HPC, NC Shares, research computing capabilities, and then their course containers capabilities as well. I'm not going to go through every single thing in detail here, but there are a few things that stand out. Obviously, the biggest one is that if you need GPU access, you have to use NC Share. We don't have GPU access on our cluster. And for course containers, there also isn't GPU access. So the course container part is really useful for classrooms, of course, because it allows you to have your designated software available to multiple users. If you're a researcher and you're just trying to do, I just need to run my software for me, then we'll talk a little bit later about how you get your own software onto NC Share, and you can do your own research there. So GPUs are on NC Share only. NC Share has a lot of CPU cores as well, 8 nodes and 1,000 cores, which is a lot of compute power. So if you have really CPU-bound workflows, that could be a really good option for you. Per node, there is less RAM compared to our cluster, however, 512 gigabytes versus 1 terabyte per node. And storage is also different for NC Share versus our HPC. So in your home directory, which when I demo, I can show you what your home directory will look like on NC Share, you get only 50 gigabytes for your home directory, which is not a lot. But there are designated work directories on the cluster where there's a lot more storage that is shared across all the users. So it's not like your 50 gigabytes is your limit for all of the work you can do. You just need to have the data that you actually need and the output for any workflows in the work directory on their cluster. And for our HPC, we have a 400 gigabyte quota set per user with 18 terabytes total for our system. If you need increased storage for something that you're doing, you can usually just put through a request, a ticket to come through to our team. Will like temporarily increase your storage quota and then decrement it once you're done. This is just to ensure that our storage isn't being starved and we're able to equally share. Everyone has access to a certain amount of storage. Scheduling is done through Slurm on our cluster and on NC Share, which is a job scheduling software that's very popular and used on HPC clusters. Another thing that often comes up a lot is sensitive data. So NC Share are very clear that if you have any sensitive data, and by sensitive I mean like by compliance and regulatory standards sensitive. So if it's I can't remember the word for it right now, but it's strictly prohibited on their cluster. So if you have sensitive data of any kind, you shouldn't use NC Share. You can't. But if you contact us, we can try and help facilitate a solution that will accommodate whatever sensitive data needs you have. Our cluster storage inherently is also not compliant, but there are other solutions that we can assist on to try and, again, get you to a place where you can put your sensitive data and you can actually, do the things you need to do. You can jump to the next one, Jeff.
Yeah, absolutely. And I'll jump in real quick. Toby's mentioned contact us a few times. That's going to be a big theme of this presentation. And there's a specific link, a way to do that and make sure that it comes straight to our team, which will be shared along with this presentation. But thank you.
So after that overview, basically our cluster and NC Share are not, at odds with each other. They both serve slightly different purposes. So NC Share is a little bit more generalizable and just has a lot more compute and hardware resources than we do. So if you have a workflow that you purely just need, an increased amount of compute for, it's going to be really easy to sign up for NC Share, get on there, do the things you need to do. But if your solution or what you're trying to do, if you're either less sure about exactly what you need to do, or you have some questions about how to orchestrate it, again, contact us, and then we won't funnel you to either solution because we feel like it. We're going to try and find the solution that makes the most sense for what you're trying to do. One big thing that I want to mention here is that while we can facilitate access and liaise between the NC Share development team and our development team, we are not system administrators on the NC Share cluster. So that does have some limitations in terms of how much we can assist with what you're doing. For example, I can't go and inspect your home directory or look at any files and try and debug things with you on NC Share, whereas that's something that we have the capability to do on our cluster. If you're getting some system errors that don't seem to have anything to do with your own workflow or your code, we can inspect that easier on our cluster than we can for NC Share. And then last thing about this slide is that in terms of long-term archive storage, the solution for that between both our cluster and NC Share is going to be to use Wasabi, which is a cloud storage platform, $7 per terabyte per month. Because again, even though both systems have storage that you're able to use, in both cases, it's kind of you use the storage you need while you're doing your work, and then once you're done, you move things off of the HPC or off of NC Share. NC Share is a little bit more strict about how they enforce it, because in the /work directory, files will automatically be deleted, I think, after 75 days. So if you forget about something and you need it and you leave it on there for too long, it's gone. And for us, that solution is with storage quotas as well. And if you have a bunch of data sitting in your home directory for a long time, we'll send you an email, be like, hey, what's going on with this? Check in, that kind of thing. But yeah.
All right, thanks, Toby. What we got next here is some use cases for NC Share and for research computing in general. These are just some examples that we have worked with. We haven't necessarily worked with them on NC Share, but these are examples we've worked with that are compatible with this system. And Leander, could you tell us a little bit about what y'all did with Gaussian, please?
So for those not familiar, Gaussian's like a mass mass spectroscopy kind of simulation. It's a chemistry software, but that's close enough to physics, and physics is kind of my background. Chemistry is just applied physics, and I like to say that to irritate chemists. Anyway, so we basically, it is, believe it or not, in the year of our Lord 2024, it came on 6 DVDs, ours. So, we got it. They purchased it. The professor purchased it. We copied it over to the HPC. We made a module for it, because there's several different versions depending on what processor instruction set you have. Like, they could use like SSE or AVX, and if that's Greek to you, don't worry about it. And so we got it all set up, and they have been running it. This professor and their research assistants have been running it for about a year now. I'm very happy. We've actually been cited in one of their papers, but we can also put that on NC Share. We've tried to make our cluster and NC Share as interchangeable as possible. So if you have some weird old software that comes on 3.25 or 3.5 inch floppy disk, we can get it up there for you, and do that. So
Awesome, thank you. And Toby, you want to tell us what you did with OpenPose?
Yeah, so OpenPose is an open source software that is intended to be a replacement for a traditional motion capture hardware and software combination. This is something that we were able to use on NC Share exclusively, because it being motion capture and machine learning AI focused software, it's very optimized to run on GPU, which again is something we don't have on our cluster. This was really cool to get work, and you can use video input from things like cameras or whatever kind of video you're trying to motion capture. It will then output data that aligns with basically the joints of the body, and in a typical format that is useful for that. So that was used by the exercise science department. We've kind of only got it to a proof of concept stage, but it does show a lot of promise for what people can do. In terms of how accurate it is, while the top of the line hardware for motion capture is going to run you hundreds of thousands of dollars and maybe be off by millimeters, OpenPose is free, and because we're at App State, it's free to use the GPU at NC Share, and it might be off by centimeters. So some order of magnitude is different, but still there are use cases where maybe you don't need the most accurate thing in order to do the motion capture that you need. And this was a pretty cool solution and thing to test. But yeah, the big theme for this is that even though, of course, you can write your own code and write your own workflows intended to be used on the HPC, you don't have to. There's a lot of out-of-the-box software. As long as it's Linux, I don't know if we mentioned that before, but as long as it runs on Linux and it's probably open source out of the box, then we can pretty much get it to work on either platform, ours or NC Share.
Open source is easy mainly because of licensing. We have to talk about how many cores are involved for purchased products sometimes.
Yeah, just yeah, the Linux side, yeah, no Excel spreadsheets. That's not what this is for. So I know some people do some pretty creative things in those.
All right, let's see. But you can also bring your own code. And Leander, would you like to tell us a little bit about that?
Yeah. So NC Share and our cluster both run a Red Hat base. If it's can compile and run on Linux, it'll probably work on that. There is a containering system. I kind of jumping down to the bottom here because I feel like maybe we led with with the wrong thing, but um, called Apptainer, which is similar to something like Docker or Podman, if you've heard those words before. Basically, it allows us to ship your desktop more or less to the to the HPC or NC share. So you can make an Apptainer container, put your software in it, and we can take that .sif file it creates, and we can put it in our cluster, or we can run it on NC share depending on your needs. It also makes it easier to like archive and come back to later if you need to maintain specific versions of stuff. We also have most of our setups have graphical Jupyter notebooks and RStudio applications available for people to use. Again, if you need GPUs with your Jupyter notebook, you need to use NC Share. But just on a web browser in a web interface called Open On Demand, you click a button, you get a notebook, and you're ready to go. The notebook software is pretty, you know, the base model. They aren't heavily customized. I know there's like a container for like a geospatial version of Jupyter and stuff, but you can obviously install packages. Tobi will kind of show you that here in a minute. And the same thing with RStudio. It's kind of the skeletal model where you can kind of customize it and add packages and stuff as you go. But yeah, that's all I've got on that.
All right, thank you. Tobi, why don't you tell us a little bit about some of the bioinformatics workflows?
So one of the biggest users of our HPC currently is the biology department. There are a lot of different um, bioinformatics workflows that staff, students, grad students, even classroom use cases for our bioinformatics class are needing to have their various software installed on the HPC, and they need to run workflows on their own data. That's a really common use case, and for us, that doesn't necessarily use a lot of GPU resources because a fair amount of bioinformatics software is relatively old and also not inherently applicable for the parallel processing that GPU offers. And even with that being said, moving some workflows off of our HPC and onto NC Share has really allowed users to take advantage of the increased amount of storage capacity and just CPU cores as well. And yeah, so that's been a really, really beneficial thing to do. And we've moved a number of grad students who were doing their work on the HPC here onto NC Share, and that's been going very well for them.
And Leander, what are we doing for classroom use?
Muted.
There we go. I got the right key combination. NC Share has a container manager. It's a Docker-based system where you can upload a container. Say if you do have a special version of Jupyter notebooks, that Jupyter Lab that you need to use for your class, they can set that up and go. We haven't had a lot of deep use of that yet. We've done some experimental stuff with a COB guy, but no, like I said, no local installation needed. They get to it through a web browser. I would say that if this is a feature you want to use, please try to get us some advance notice. Not a week before class kind of thing, just to give us time to kind of experiment with it and make sure everything is good to go. So, yeah.
All right, thank you. Whoops, got too click happy there. All right, to get started with NC Share, you'll have to register an account with NC Share, and all of this is in the link documentation that I think Lauren already put in the chat. Ultimately, if you follow our documents, it'll take you here and you register, you log into Open On Demand, and when you do the registration, it's going to send you to our login page. So that'll be familiar. Log in with your university credentials, and then you'll have to fill out a little questionnaire about yourself, and then it takes a few minutes, but then you'll have an account. And then you can access the research or the classroom side of this thing. Now that just gets you into the CPU side of their cluster. Get in there, mess with it, see what you think, and then if you're ready to run a job on a GPU, submit a research computing request, and we'll get you put in the group that lets you do that. And we don't have direct, infrastructure access to the NC Share cluster, but we do have a meeting with their staff every couple of weeks, I think, where we talk about issues and stuff. So just, if you have any trouble, let us know. We can try to help here. And if it's something we got to escalate, we'll take care of that. For the on-premise HPC, if you want to get in there, you can submit a research computing request and we'll just get your App State user account set up there. Either of these systems can be accessed through the web, through a system called Open On Demand, which we'll show during the demo. And of course, if you're familiar with SSH to a Linux system, you can access either system that way as well. And did want to talk about what we're able to help with, what my team's able to help with. We help with account provisioning and access, system environment job issues, any trouble you might have, running your jobs on the cluster, any trouble you might have getting things scheduled. We're happy to consult on storage. Again, on the clusters, they have lots of storage, but it's fast and expensive, and that's for live, data you're working on. For archival storage, talk to us. Wasabi, $7 a terabyte a month. We'll get you set up. It's very easy to use. We can help out with the classroom specific setup with the appropriate advance notice. And as I said, we regularly communicate with the NC Share folks. Just bring us your code scripts and algorithms. We are not really software engineers, and we don't have the capacity to, teach how to use Linux, teach how to write software. We're happy to help as much as we can, but there are just limits to what we're to what we to how many people we have ultimately. And the research design and consulting, that's very much outside of our wheelhouse. We can certainly point you at some other areas on campus. And then of course your domain specific expertise, you write the code, we'll run it. And of course, last slide here is our website, reswiki.appstate.edu. And there's a big button called Get Help. Click on that. In fact, let me switch the share over to this. I wanted to just show it real quick here. Go to our website, help and access, and then right here brings you to the ticket. Just put in what you need, hit submit. It shows up to everyone on this call here, and one of us will take it and work on it. Going back to the website, come on down here and click on NC Share, and here is everything you need to do to access it for research. And again, if you want to, if you need help with it or you want to get access to a GPU, submit a help ticket and let us know. And with that, that's all I've got. Back to you, Grace.
I was muted as well. Okay, excellent. Thank you, Jeff and Justin, Toby, and Leander for the information. I'm going to ignore the alphabet soup sloshing around in my head on a Friday right now and go ahead and thank you for the time. Thanks everybody that joined live. This is our final session in the RIEEE webinar series this spring. If you're interested in a particular topic area or potentially presenting during one, please reach out to us. We'll go ahead and stop the recording now. This will be available on our YouTube channel here soon.